learning. So deep learning is now a buzzword. Okay, and I'm simply introducing you this deep learning. So those who are interested in having the career in machine learning, artificial intelligence or deep learning, they may further explore this course of deep learning. Okay, so deep learning actually is a branch of machine learning only, and that is based upon the artificial neural networks. So we may say that deep learning is the extension of artificial neural networks that we have studied, right? So deep learning is particular kind of machine learning that achieves great power and flexibility by learning to represent the world as a nested hierarchy of concepts, with each concept defined in relation to some simpler concepts and more abstract representations computed in terms of less abstract ones. So this is a formal definition of deep learning. So I'm going to explain you what does this mean, right? So simply remember that deep learning is extension of artificial neural networks. So in artificial neural networks, we are having multi-layer neural networks wherein we can learn complex non-linear functions to solve the particular problems, right? But many times it happens that we are having the problems under consideration. Those are so complex that even the features, those need to be provided to our artificial neural network. It is not possible for us to extract the features to provide it as input to our ANN. And that is why this concept of deep learning evolved. So deep learning actually has the power and flexibility, and that will on its own learns how to represent the input in terms of features. So what I mean by that, let us see now is actually comparing the machine learning ANN. Under machine learning, we are having artificial neural networks, right? So ANN in machine learning is compared with deep learning here. So in machine learning, suppose we are solving one problem. So what we would like to do is we would like to detect a car from some image. Correct? What we want? We want to detect a car from image. Right? So if we go with a machine learning algorithm, machine learning approach using ANN, then what we need to do? If I want to detect a car, then what I need to do is I need to extract first the features. Those are describing that car. Right? What we mean by that? The features of car might be, I am simply giving you one example. So what might be the feature of car? Maybe the presence of wheels. Right? So if I want to take this as one of the features, presence of wheels, then what I need to do is I need to describe how a wheel looks like in terms of the pixel values of the image, right? So sometimes it becomes very difficult to describe such kinds of features, right? And in machine learning, what we need to do is manually we need to decide upon which features we would like to extract. Yes?
In machine learning, for feature extraction, means what are the steps, or what we can do for feature extraction?
Yes. Depending on the application, we may have different methods. But this feature extraction requires human intervention in machine learning, in ANN. So simply,
Yeah, yes, yes, ma'am.
see,
But if we have a continuous data, means continuous data, for
yes,
that means what are the basic feature extraction methods we can do?
yes. See, if I'm having, see, input, here I'm considering the input as the image, correct? And I want to extract the features from this image, right? So I want to describe the car in terms of some quantified features. What are the features? Features are some quantities, those we are extracting from our data. So using the features, we are describing our data, right? So if I'm having series of numbers, or what this input is, image. If I consider image as the input, then I'm having this two-dimensional array or matrix, right? I may have one-dimensional series also as input, whatever may be my input. So in my input also, I'm having lots of numbers, right? So whenever I'm trying to extract the features, depending on the application, the feature extraction methods vary. So for example, if I'm describing image in terms of features, suppose I'm having the textural data, I'm having the color data, then what I can do is I can extract the textural features. So maybe the textural features include whatever is the data here. I may use the standard deviation, I may use the variance, right? I may use the skew, I may use the homogeneity. So there are several different kinds of parameters. Those I can extract as features from this image or from any kind of data. So it depends upon what kind of application you are dealing with. There is no standard rule like these should be the features. And that is why human intervention is there. So the person who is working on the application, that person will decide which features need to be extracted initially, right? And after that, if, say for example, I decided to extract say 100 features out of the input data, then machine learning is having the algorithms for feature selection. So we have gone through these algorithms. So out of 100 features, maybe not all features are meaningful. So then machine learning algorithms can be used to select the most prominent features out of that. But initially, the person who is dealing with that application needs to extract the features or needs to decide what kinds of features we need to extract. So simply,
Ma'am,
I was explaining this input as the car. If I want to detect a car from the image, I need to describe this car with some features. So what might be the feature? Maybe one example I was giving, the feature might be the presence of wheel, right? So if I'm having the presence of wheel in my image, then that might be one feature of presence of car. But now it becomes difficult for a person to extract this kind of feature. How to describe this presence of wheel in terms of pixels, because this image is in terms of pixels. That means the intensity values we are having. Okay, so many times it becomes difficult even in machine learning to extract the appropriate features. So once the features have been extracted, then we may go with some machine learning algorithm like ANN, and then we may classify whether in that particular image I am having a car or I do not have a car. Likewise. Correct? Are you getting me?
Yes, ma'am. But ma'am, can you same explain for the continuous data?
Yes,
Here we are taking
yes,
image.
right. In continuous data also, we may come up with similar such kinds of parameters based upon that data. Right? So in continuous data, we are having some, say, thousands of samples. Are you getting me? I may have
Yes, ma'am.
thousands of samples. So based on those samples, I may compute for the set of samples, I may compute these kinds of parameters as well. Statistical parameters, I mean to say statistical parameters, depending on distribution of this data. See, usually the data can be distributed in normal distribution, Gaussian distribution, and so on. Right? So usually the data is distributed like this. So if I am having such kind of a data distribution, then lots of parameters I can extract. I can extract standard deviation of this data. I can extract the variance or some other statistical parameters. And these parameters actually become my features. And further, after extracting those features, I may input those features to my ANN. And my ANN will give me the output, whatever is the expected after learning the ANN with some training data set. But what I want to emphasize is in machine learning, manually we need to think of the feature extraction. So human intervention is required. Right? And in such scenarios where my input cannot be described properly. So how I am going to describe the wheel now? So it becomes very difficult to describe the wheel of a car so that I can identify, I can detect the car in the image. So to overcome this problem, we are having the concept of representation learning. Representation learning. So what we mean by this representation learning? The algorithm learns the features on its own with minimum human intervention. So in traditional machine learning, we are extracting the features and these features are being given as input to my machine learning algorithm. But in deep learning is a kind of representation learning. So in deep learning, what happens is I am simply giving this car image as input. The human intervention is not there. So feature extraction and classification task, both the tasks are being performed by my deep neural network. So why this word has been introduced deep? Because if we compare it with ANN, I am having comparatively lots of hidden layers. Right? So our network itself is very deep, having different layers and different activation functions. And that is why it is called as deep learning. Right? And here the basic difference in machine learning approach and deep learning approach is in machine learning we have human intervention for feature extraction, but in the applications where it becomes very difficult to extract the features, here the deep learning helps a lot, wherein we are simply giving input as the image. We are not at all going to extract the features from the image. The features are automatically extracted by my deep learning network. Right? So that is the basic difference. So deep learning can solve this problem of representation learning by introducing the representation that are expressed in terms of some other simpler representations. So to understand this, I am having here one illustration. See here, this is one deep learning model. So what I mean by representation in terms of some simpler patterns. So see this figure. Okay, so if I am using the machine learning approach, then describing this image in terms of features might be difficult. But if I go with deep learning, then what happens is whatever are the visible features, the input pixels of this image, this entire image is being presented as the input to my deep learning neural network. And what happens is, see here, I am having first hidden layer, I am having second hidden layer, I am having third hidden layer, and so on. Actually, these neural net or these networks are very deep. So lots of layers. Right? And what this deep learning neural network does is, whenever the input goes to first hidden layer, then what happens is, this first layer may be responsible for finding out the edges in the image. Right? So whatever are the edges in this image, those are being identified. In the next layer, it may happen that the second layer finds out the corners in the image or the contours in the image. Then in the third layer, it may happen that the third layer may extract the object parts, right? Then in the next layer may be more bigger parts or the objects can be identified, and so on. So every layer in deep learning is responsible for extracting some kinds of features. So this will become the input for the next layer, and the next layer comes up with more representative pattern. Then this output of this neurons go as input for the next layer, and this layer may come up with more understandable pattern or object, and the process continues till the output layer. So ultimately the neural network, deep neural network, goes on learning from smaller units of abstraction to the better abstraction of the entire object that is present in the image. And ultimately it happens that my deep neural network is giving me the appropriate class for the object which is present in my image. So this is one example. So deep learning networks are more popular in image processing. Typically, the convolutional neural network known as CNNs are being used for image processing tasks. Right? If I am having temporal series, videos or audio, then maybe the recurrent neural network or the LSTMs are being used. So this is entirely a new course to learn as deep learning. So we have introduced in our machine learning how artificial neural networks work. So deep learning is simply the extension of ANN. Right? And the major difference is deep learning networks help us to extract the features, to represent the input. So the human efforts are minimized in deep learning. Right? So I hope you must have
Ma'am,
understood this. Yes.
ma'am, which is easy to learn, machine learning or deep learning?
See, both are having the advantages and disadvantages, right? See, I have here in this on this slide, I have listed few points. If you want to go for deep learning, right? So the basic requirement of deep learning is you should have the huge amount of data available for learning. If you go for deep learning and if you are not having the significant amount of data, then deep learning algorithms will not work well. So if you are not having large amount of data set, if you are having limited data set, then it is better to go with machine learning, traditional algorithms. Right?
Ma'am,
So that,
large
yes.
amount of data means in
In
quantities, how
terms
much?
of, yes, in terms of thousands, millions, trillions. If you are having lots of data, then obviously your deep learning algorithms will work well. Say for example, if I am using some deep learning neural network for image classification, then I may prefer to use the data set in terms of millions of images. Right? So if I am having that much data available, then only I'll think of going for deep learning. Because to this first point, the basic requirement for deep learning is we should have large amount of training data set. Secondly, the deep learning algorithms are heavily dependent on high-end machines. So if we are trying to process lots of data and if we are trying to learn by making use of very deep neural networks, then obviously the machine or the computer system that we are using, that should have the high-end configuration. So typically the GPUs are required for processing that amount of data with deep neural networks. So the deep neural network algorithms are heavily dependent on high-end machines. So if I'm having enough hardware requirements with me, like GPUs, high-end processors, huge memory available, then definitely I can go with this deep learning algorithms. Okay. The next point that I would like to mention here is the deep learning algorithms require lot of time to train. Because we are having huge amount of data and that data is being used for training, the longer time is required to train my system. Right? And that too, for training, I'll require high-end machines. Right? Whereas if I go with machine learning, there is no need to have the high-end machines and comparatively the training time is small. Okay. Now, if I want to test my data, then no doubt once my deep neural network is trained, very small amount of time is required to test my data using deep learning. Right? So these are the important points those we should understand about deep learning. Okay, so I hope you must have understood these concepts. So this is end of our